how do you call non-composite materials?
Non-composite materials.
Normal materials or used?
Materials.
Good.
Yeah.
So what would be the difference in price between materials and composite materials? So let's say we have a project, we want to incorporate a composite.
Depends. I cannot say because I never did a study really related to prices. I'm an engineer. I'm good with numbers, but on the other side. Yeah, so I'm not, yeah.
It actually depends on the type of composite materials you want to use. If you want to use the resins that you have to cure in an autoclave, you need to have specialized equipment that's really expensive, and it depends on the scale. Really depends on the scale.
And it depends on the, it depends on the scale, and I think it depends also of the composite material that you want to use. For example, if you want to use carbon, or if you want to use glass, or if you want to use, what type of resin do you want to use? What strength do you want to have? What are the properties that you want to implement? Composites, for me, they're quite versatile. I mean, you can play with it, and you can insert or get rid of some strength, some properties, to say so. So depending on what material, normal material, you want to use and what you want to substitute with composites. So I cannot say that are twice more expensive or less expensive. It depends. Yes, please.
Is it?
Does it answer more or less to your question? Well, I cannot give you a price, that's for sure, but it's okay, more or less, or
yes.
Yeah,
maybe,
yes.
maybe to help with that, what's the biggest cost when making carbon fiber? Is it not the labor cost? Is it not super labor intensive?
That's indeed, yeah. The operator has to be very, very well trained. That's indeed, yeah, because also the environment has to be different. It's different from making just a chair, a plastic chair, a normal plastic chair, and a composite chair, if you
I
want.
would say the volume of production is one of the main parameters.
That's what he said with the scale.
Another thing that's very important, you have to work in clean rooms.
Yes, so the environment,
And
it's
also you
different.
need molds. Mandatory.
And the complexity of the molds.
So depending, you can do you can do very easily. And I remember that university we had a training like this. You can do sandwich structures. That means a laminate. You make some glue and then you put the honeycomb and then you put some glue and then you put the laminate. But is it okay? Is it not okay? You have to test it. You have to see where you want to use it, how much you want to use of it. So it's depending.
I think that's the main difference for now, I think, between composite materials and then the usual materials that have been used. Like, for example, in aerospace and so on, it can be used because it's very specific usage. And for example, for airplanes, one of the main costs over the lifespan is basically the fuel use and so on.
Correct.
So basically, the cost of the material is saved by the savings in fuel and so on.
Yeah.
So it's the very specific kind of usages. And for example, high-end cars can use it because they have the low volumes and such.
You don't have to forget that composite usually it's lighter than material, than metallic, than than normal materials. Yeah. So in that case, yeah. It's okay to use. I mean, it's better maybe to use composites because it will attenuate during time. But if you want to make shoes or glasses, I don't know. I really don't know.
If you want to pay a lot per piece.
Yeah. High-end shoes, maybe, I don't know.
There are also some restrictions. As you can see on the airplane, all leading edges are metallic because composites are not that good resistant to impact.
Yeah.
And not only, you have also the parts, like for the slats and flaps, the parts that are retracting and making exactly. So those are metallic as well. They're not yet composite to say so. I don't know if they will be. I have no idea. But I've seen during time that they are implementing more and more composites in the airplane as well. Stringers are made of composites, so the parts that are keeping the shape together. They are made from composites and so on, so that are basically
I
made
guess,
from metallics in the beginning.
They're trying to make, for example, the hulls out of basically one piece from one composite piece, because also with composites it's a lot harder to make it in
Yes.
several parts.
In pieces,
So
yeah.
because always with composites, the point where you add two parts to fasten two parts together, that's always going to be the weakest point. And so if it's possible to manufacture something in one piece, then you can more easily
It's better.
gain by using composites.
Yes. Sorry. Yeah? No? Yes, please.
I have two questions.
Yes.
So first of all, when you do calculations, which software do you use? Engine? The engine you use?
I don't use any soft. No, but there are many softwares. I mean, Patran, Nastran, ANSYS.
Because
There are a lot of softwares that you can use. But yeah.
yeah,
please.
because I use Siemens NX, and it's very easy for linear strengths, but for non-linear it's quite hard. So that's what I'm looking for. Maybe other software.
Maybe Patran, Nastran, but that's not.
difficult
It's
everywhere.
non-linear. Yeah, non-linear. It's difficult by the fact that it's non-linear. You know. I mean, yeah. But
And my second question
Yes.
is there a region in the world where you think they're better in producing composites? Because like if I want to produce textiles, I go to, for example, India or whatever.
Better that
And if I want wood, then I go to Poland, Romania, whatever.
Yeah.
But is there a region that you know that's, or you don't have any clue?
Well, if you want to speak from my heart, I would say Belgium and Romania,
Okay.
because I'm coming from Romania. But to be honest,
Because, yeah, I have a guy in Belgium, but
I have no idea.
it's not upscale.
I've worked previous. I think it depends on the culture of the people of the company as well. In my opinion, I mean, it's not really related to. In my opinion, I'm speaking personally. It's not really related to a country, or maybe it is. I don't know, because the culture is coming also from the country, from the environment. But I think it's important also the culture of the company itself, because I've seen in the same country, to say so basically more or less the same state of mind, the same culture. Composites done very well, and composites done not so well. See, so.
Yeah.
I cannot say, I don't know, I cannot say that in Europe it's better, or in America it's better, or in China, in Asia. I have no idea. Really, I have no. I think it depends on the production itself, on the culture of the company itself.
It depends also what you want to do with the material. If you need certifications for it, it's far easier to get the certifications from the US or
it's
from
true.
Europe.
In China, they are producing also composites, and
Yeah,
some
I
of
know,
them
but
they
I
are
have
good.
difficulties with
Yeah.
those productions, so that's why I'm looking for.
I know. Yeah, it's China. Okay. Yes.
One of your slides you mentioned the direction of how
Yes.
you are allowed to put the fibers, but what is exactly there?
Yeah.
What is exactly the reasoning behind it specifically?
That's a good
Because it's-
question that I cannot answer, because I think it's related to the direction of the strength.
Yeah,
So
but
basically-
if for example you want
you want to put a 25 or
in
something.
all directions.
Well, in
it would
repairs
be
you can.
super expensive, of course, considering you're going.
In repairs, you can, honestly. I mean, I've worked in the repairs, so in repairs I've seen fibers put in all the degrees, but that means that that area will not be able to support the strength as it was designed to. So if I'm talking in terms of aerospace, the ARF, so the capability of the part to support the strength will decrease. Why? Sorry, but I don't have the best answer today.
Okay.
Any other questions?
But,
Yes.
Just if you do it like bidirectional, you block all the degrees of freedom. So why should you do 360 degrees? That's
If I
Not
remember well
efficient.
from university, something related to the matrix of stiffness and something like this, but really it's far away, so I'm not gonna make now. I'm not. Don't even remember to make now the entire theory.
Maybe to keep your sandwich symmetric. If you use
That's also yeah.
if you use
Indeed.
very thin degree, maybe it will be very hard to
Indeed.
But probably it's got to do also with the fact that you're not going to apply a whole bunch of layers
You
together. But
cannot-
let's say you're going for a very structure that needs
Thin.
to be very strong in all directions. To basically know why you would do those 3 degrees each time, instead of, for example, going with a more smaller change in direction each time. For
What
example.
I can support, and I know that it's important that during a repair, if you want to more or less ensure the same capability of strength of the part of the area, then normally you should, if you take out a ply that was put at 45 degrees or minus
You
45,
need
then
to
you
put
have
it
to
the
put
same,
it at
of
the
course.
same direction. Between us, it's not totally respected, but well, that's why there are calculations and so on and so on. So
But you will try to put more plies on the direction of the loading.
yes,
But you have some concern for manufacturing symmetry, because if it's not symmetric, when you cure the composite, it will take special check.
For the curing maybe.
Yeah, yeah.
And for the fastener as well,
for
you
the
need
fasteners, yeah,
to
indeed.
have more a mix of on all directions.
All directions, because
to have
it's
good properties for the load transfer.
for the load,
to the
yeah.
bearing.
Yeah.
It's curing.
Curing, it's it's when you have the material, you have the fibers, you have the matrix, then you have the resin, the fibers and the resin, and then you have to do something with it, because if you just put some resin there, it will not stick together. So you have to cure it, you have to put it in an oven, and then in the oven the resin will flow and will go inside the fibers and will make it be together, and will become like a plastic. The composite in that sense will have the feeling of a plastic, if you want to, and will be stiff.
And that's curing. So it's
That's
cooking
curing.
the-
The process of making, transforming, and making the composite, that's curing. In the autoclave, what Mario said, that's the oven.
Alright.
Yes, please.
Maybe it's a stupid question given how composites
There are no
made.
stupid questions.
But then we already print 3D print composite materials.
Well, I know that we can 3D print something similar to composites, but maybe not the traditional composite to say so. But I know that it's possible to print some stuff. Yeah.
You can find short fibers and long fibers.
Yeah. So yeah, it's possible.
But on small scale, to do, for example, a sample for your
Yeah.
mass production,
Yes,
you
yes.
would have to 3D print to make
For-
a cheap.
I think you can 3D print more. I've heard even how do you call them, human fibers and stuff like this.
That's possible.
So normally it should be possible to print.
You can use other methods that are functional. You don't need to use a resin that's hardened only on activated on high temperatures. You can use a resin that can be hardened at room temperature. And with a small vacuum pump and you can 3D print the mold.
Okay.
And you can use some sort of a small vacuum pump and cure it at room temperature. It works just fine.
Okay.
Far cheaper than 3D printing the whole
Okay.
thing.
Then there's even more efficient.
Yeah.
Thank you.
No problem.
Guys? Yes.
Yeah. Maybe related to the questions raised before.
Yes.
Is it easy to mass produce in the future, do you think?
Yes.
This kind of
Composites, in my opinion, yes.
But currently there is no way, currently there is no mass production.
There is, well, it depends what you call mass production. I mean, everything made from composites. Well, it could be. Yeah, we can arrive there. I mean, everything is developing nowadays. But today we still have, because we need to reduce costs. Our managers ask us to reduce costs. Our politicians ask us to improve the quality. Our, I don't know, economical guys ask us to pay less, and so on and so on. So in the end, nowadays the production maybe is not as we hoped. I mean, the engineering department is creating a fancy wow product from composites, but then when you arrive to production, you will see that maybe it's not that possible, you know. So see, for example, Concorde. Yeah, it was a master engineering aircraft, and in the end, it still is. Yes, I agree. Yeah. But yes.
The BMW i3 has a full carbon. The whole shell is full long fibers carbon, and it's mass produced. So that's the answer.
Which product you said?
The i3, the BMW i3, and the i8 as well.
Yeah, that's why I said that in my opinion it should be possible. It should be. Yeah.
But volume is still quite high. Actually, it's around 500 vehicles per week.
Okay.
Per week.
Yeah.
Other questions or?
Well, if you ask, I have a question.
If she asks, so you have a question for her.
How do you make carbon fiber?
How do you make carbon fiber?
How do you make a
from
fiber? I know carbon from my pencil, which has a carbon.
Yeah. How do you make carbon fiber?
You buy it.
Yes. Yeah. I call my supplier and I say, please give me some carbon fiber.
It grows on very
It grows
specific
on,
trees.
No idea. But it's a good question.
Actually, a really good
Sorry?
question.
Carbon fiber is a woven material.
It's an woven material.
Woven.
Ah, yeah, it's a fiber. It's a textile fiber. Yeah, it's a fiber. But it's not okay to touch it.
Yeah. No.
I mean, you can touch it, but wearing gloves.
Thank you.
You should really wear masks and stuff. Yeah. Because it's there's very easily like small particles that come off of the fibers, and if you work with it too much, it can get into your lungs. It's the type of small particles that don't get out of your lungs.
And going back a little bit maybe to your question, that's why I said that or to you, I have a short memory. I'm a girl, so it's okay. So the idea is that the environment in which you produce, also for mass production, it's very important. And the people should be well trained to be aware of the fact that they are using something that is not maybe as common as everything else.
Yeah, it's quite
normal
bad for
materials.
your health, and also your skin is easily irritated by the fibers.
So
Speaking
it's
from
never,
experience.
so it's never out there in the open. It must always be properly embedded in the material.
You can touch it, but with gloves. I mean, you have to be protected. Yeah, you have to wear some stuff in order not to touch it directly with your skin. That's the idea.
But I mean, in the little table there, if you were to embed like carbon
but
fibers.
with resin, if there's a resin around it and so on, the fibers are basically